Alright, so now example 7, we get to go to word problems. Yeah. Alright, so we're looking at alcohol and the risk of a car accident. So it's a real life situation here about people when they drink and drinking too much and they get into an accident and all that good stuff. So we're going to talk about the risk of it and the chance of getting into a car accident, all the good stuff. And with this, I would say personally, if you don't have to drink, don't drink. It's not that important that you do, because it impairs who you are and it changes you. So I don't think you should, but it's up to you. You can always do it if you want to, but if you don't have to, I would say don't do it. Don't do it. All right. So here we're talking about again alcohol and the risk of a car accident. So here I'm going to go ahead and bring this down. And if you want to, you can go ahead and stop the video and go ahead and start writing this down, because I want you to write it all down. But I'm going to go ahead and read this in a few seconds. So if you want to stop it and write it down and then keep going on afterwards, that's fine. So go ahead and stop the video now, and then I'll read. Okay, so let's go ahead and read the problem. It says medical research indicates that the risk of having a car accident increases exponentially. So we've talked about graphing exponential functions and all that good stuff, and we've now been talking about exponential equations. So that's what we have here, exponential equation. So the risk of having a car accident increases exponentially as the concentration of the alcohol in the blood increases. The risk is modeled by this equation right here. R equals 6e to 12.77x power. And here, the x is the blood alcohol concentration, and R is going to be given as a percent, so we're going to just take that number here. We're not going to worry about the percent, changing it to a decimal. We're going to keep the number they give us. But R is the risk of having a car accident. Now, our whole thing here, the question is what's in red here. What blood alcohol concentration corresponds to a 17% risk of a car accident? Or to make this simpler, what is your blood alcohol concentration that you're going to have at least when you get on the road, you're going to get into an accident 17% of the time. So we're going to talk about after this too. We're going to talk about the chance of getting into a car. You will get into an accident and possibly kill somebody, or kill their wife, or kill the baby, or kill a pregnant woman that actually is in a car trying to go home, and she killed the baby and the mom and all the good stuff, and the family. Yeah, just horrible. So yeah, we're going to talk about how much your blood concentration has to be in order to be able to get into a car and you're going to get in an accident. All right, so here's the equation they gave us. So R equals 6e 12.77x power. All right, so let's go ahead and take a look at this and actually work it out. So let's talk about it. So we said that R is our risk, and it's going to be given as a percent, so we're going to use the whole number there. So our percent here is what number? Right, 17. Right, and we're trying to find the blood alcohol concentration, so that means we're going to try to find what X is, right? Because we said up here at the beginning that X was our blood alcohol concentration. So X is the blood alcohol concentration. So here we're going to put 17 in there. So we're not going to change to a decimal. So do not change to a decimal, because it says it's given as a decimal, as a percent. So we're going to use that number. Not change it to it didn't say change to a decimal. It just says it's given as a percent. All right. So we're going to put that 17 in there, and we're going to have to solve this for X. We're going to have to get X by itself. Get that so we can find out blood alcohol concentration for that. So the first thing, again, is like we did before. We're going to isolate the exponential function. We're going to use one of the rules. Then we're going to go ahead and solve it out. So here, our exponential function is this part right here. It's the exponential function. And so that means this 6 has to move over to the other side. But how do we get this 6 to the other side? Or in other words, what's happening? It's 6, is it 6 times E or 6 plus E or 6 what? And hopefully everybody's saying that too. It's 6 times E. So if it's times, we have to do the opposite. So we divide by 6. Let me get that to cancel out. And here, do not put 17 over 6 in the calculator. We're going to leave it as it is, because if we get to a decimal here and actually round it and all the good stuff, it's going to completely change our final answer. So do not round this number, or do not put this into calculator and get a decimal answer until you get to the very end. Okay, so we said that we're going to isolate, natural log it, then what? And then so on and so forth. All that good stuff. Isolate, natural log it, simplify, solve. You remember that, right? Isolate, natural log it, simplify, solve. Isolate, natural log it, simplify, solve. You remember that? You guys remember that, right? Okay, so I hope you do. I really, really hope you do. All right, so at this point, let's go ahead and take the natural log of both sides. So this is our step 1 to isolate. Step 2 is going to be to natural log it. So we do natural log of both sides here. And what do we know about natural logging E? What do we say about that when we said we natural log it? So that was our step 4. That was our step 3. That's our simplify stage. And we said natural log and E cancel each other out there. So we're left with natural log 17 over 6 equals 12.77x. So that was that one. Oh no. That was that one. And then the last step is to solve. So here we get to divide, here get x by itself, so we solve it, so we divide, let's change it to black. We divide by 12.77 over 12.77. We get those to cancel out. We get x equals all that great number right there. So we need to go ahead and put this into the calculator so we can get a decimal number and be done with it. Alright, so we're going to put that in the calculator. So we're going to, again, do alpha y equals. So alpha, the green button, and y equals. We're going to do natural log. And for this one again, for natural log, since it's a fraction there, we're going to do alpha y equals again to do another fraction bar there. We're going to do 17 over 6. So again, we did natural log, we did alpha y equals, then we did, and enter, and then we did natural log on the top, and we did alpha y equals again. And we did a fraction bar so we can go ahead and get the 17 over 6. And then again here, go and close off that part. So we have natural log parenthesis 17 over 6, close parenthesis. And then we go down on the bottom and do 12.77. And we hit enter. And it should give you a decimal number there. That's very important to know. Very important to know. Alright, so if we get the answer, we get that x equals what? About 0.08, let's say 2. Let's find 3 decimal places. So about 0.082, because that 5 behind the 1 takes the 1 up to a 2. So about that much. Now, what is the legal blood alcohol concentration? So this is our, so first off, before we do that, let's write that in the sentence so we can make sure we understand what's going on. It's not just a random number. So the blood alcohol concentration of BAC, you'll hear that over and over again. So they don't really say blood alcohol concentration a whole lot, they say BAC. So the blood alcohol concentration that corresponds, so we're using the words from the actual question, to a 17% risk of an accident is 0.082. Now, what is the legal BAC that you can actually have, blood alcohol concentration? Hopefully everybody knows that, especially the ones that are driving, that ones that do drink and stuff. I hope you do know that. I hope everybody knows that's 0.08 is the legal limit. So that's over the legal limit. So even the 17% chance of getting into an accident means that you're over the limit, which you can get in trouble for that really badly. So make sure that you're careful with all this great stuff. All right, and before we finish this one, I'm going to go ahead and look at it. So what's the chance of, what is the actual blood alcohol concentration that you know that you're going to get into a car and you're going to get into an accident? So 100% risk of an accident. So we have the same equation, R equals 6e to the 12.77x power. And hopefully there's actually a shortcut that we can do for this one, but we're going to substitute R in that 100 for R, because that's 100% risk. I hit 100% chance. And let's go ahead and solve this out really quickly. But there's also a quick thing that you could do, but I'm not going to tell you. Hopefully, maybe you might see it at the end. If you don't, it's okay. If you do, that's wonderful. It means you can have a shortcut for this. All right, so we isolated it, the exponential function. We did natural log on both sides, natural log it. All right, so then we simplify it down. We get the natural log and e to cancel. We natural logged it and got canceled out things. So the natural log 100 over 6 equals 12.77x. Then we divide by 12.77x to solve for x. To solve. We like to solve. Solving is good. Solving is really good. So we get x equals all this wonderful information. Yay! Woohoo! Yay! All right, and then again we put that in the calculator and we get a decimal answer again. And once you put all that in, we get a really, 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 really big number, big decimal number. So we get x equals 0.220. So that's the chance of getting into a car if you have your blood alcohol concentration like that. So I'm not going to write a sentence for that one, but you can write a sentence for that, and it's going to be the exact same thing as we just wrote, but instead of doing 17%, you put 100%. Now, I want to do that because I want to kind of show you, for those that don't know about it, the charts for blood alcohol concentration. Now, with that, I'm going to post that up here on the screen so you can see it, but also I'm going to put it in the next video so you can figure out what's going on. All right, so I'll see you in the next video.